everyone. I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic for discussion is Vector Differential Calculus, in which question bank discussion. The first, the Vector Differential Calculus regarding that module, what all there, even the starting vector and scalar point function from which up to integral theorems we will be discussing. So far from scalar and vector point function regarding the definitions, very short answers will be playing a role as short answers in the question bank part A. That is the total question bank, the system for this module, Vector Differential Calculus, for the subject Mathematical Transform Techniques. Module 4, it is playing the role. Nearly 50 questions are there which are prepared, and they are divided into 3 parts. Short answers 20 and long answers which come under part B, nearly 20 are there. The final one, part C, nearly 10 questions, problem solving and critical thinking. This complete question bank which is prepared satisfying Bloom's taxonomy. The Bloom's taxonomy totally 6 levels. The first 3 levels satisfying this question bank which is framed. So now this is the model of question bank, Institute of Aeronautical Engineering. The branch we have taken for Aeronautical Engineering. This subject which is for Aeronautical Engineering, AC, EEE and Civil and Mechanical, all these branches, this subject will be taught. Now, the subject name which is written here, this is the format of our college question bank system. The code for this subject is AHS C07 and the regulation is R20. The subject which is being taught to first year students, second sem. That is also one of the reason the previously the Blooms we have seen it. 3 levels. Up to 3 levels the questions which are prepared. Total, actually the Department of Mathematics put together this question bank system which is framed. Dr. S. Jagadha, Associate Professor myself, is the course coordinator of this subject. So we can see now the Bloom's taxonomy. According to Bloom's, 6 levels are there. So the first level is, remember, that is so far what we learnt, just we will be recollecting and recalling. Such type of questions are there in the question bank. It will come under, remember, that is Bloom's first level. Understanding those definitions, we will apply. We will be, suppose the formula which is there, that formula we will do comparison with our problem. What is the connectivity of the formula and our problem? That is Bloom's second level understanding. The remember and understanding put together, we will apply to the solution of the problem, that is applied. So completely these 3 levels are satisfying, and the main thing, the subject is being taught to first years. So only 3 levels the questions are prepared, which is framed in a very well defined manner. The 4th level is analyze. So the analyze, suppose if the questions which is being taught, the geometrical figure, one geometrical figure which is taught, the student should analyze what about the other so many geometrical figures. Such type of analyzing study should be done. So that is comes under analyze. So what we analyzed, we will do the evaluation. and the new one will be created. So these are all for the second year BTech students onwards will be dominating for the mathematics subject. So now here the module 4, vector differential calculus. This is the question bank of format which is available in our college website, Institute of Aeronautical Engineering. So we can see here the first, the 4 questions. They are, remember what is scalar point function. The definition just we have to remember and we have to write, recalling, even vector point function, and what is curl, what is the divergence, what is a Laplacian operator. Whereas here the 5th question is apply, it is there. For the apply, first we have to recall what is a curl F. So the curl F formula how, which is connected to our problem, Bloom's second level, and we will find the solution with the help of first and second level. Third level, applying, we will reach the solution. So this is the format, the 3 levels is satisfying this question bank for model 4, which is framed. Here we can notice it here. This is course outcome. Totally 12 course outcomes are there. So these particular questions, they satisfy which course outcomes also here in the format which is written. Here we can see it, these 2 levels. Now this is apply, it is there. So what are the 2 levels we are going to recollect? That is also which is here written. Every other question against which is written. So now in this particular video lecture, so the question bank nearly 50 questions are there. How many questions possible? Not complete a solution. To reach the solution, what are the steps? What to be recalled? What to be understood? And how to apply? That main steps we are going to discuss in this complete question bank discussion on vector differential calculus. If complete solution is required, already nearly 11 videos are done. The same topic, vector differential calculus, the complete solution which is available in YouTube, it is already released. So now first we will come to our questions, short answer questions, which are in the question bank. Vector differential operator. That is the vector differential operator. The symbol which is there, the vertical triangle, it is there. That is grade. So the grade is nothing but I, J, K. There is a mutually perpendicular vectors. The dou, which is the symbol for partial differentiation. So with respect to x, with respect to y, and with respect to z. If any function which is given, the function will we have to do with respect to x, with respect to y, and with respect to z. So the grade, the formula. So that we can see it, the gradient of your scalar point function. That is like pi of x comma y comma z be a scalar point function of position which is defined in some region of space. So the next one we can say it, this is the vector function, that is I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z, which is known as a gradient of pi and denoted by grade pi, or this is the mathematical symbol that can be written. The divergence of your vector, we can say it. Let f be any continuously differentiable vector point function. That is continuous, it is there. Limit x tends to a plus, that is x is greater than a at the point what is the value of a, f of x minus f of a divided by x minus a. Similarly, limit x tends to a minus that is x is less than a, the same formula. These two values, if they are equal, then it is differentiable at the point x equal to a. So we can see now I into dou f by dou x plus j into dou f by dou y plus k into dou f by dou z, which is called divergence of f. So which is denoted by div f, that is a grade dot f. This is the mathematical notation for divergence. This is called a scalar point function. So divergence of your vector, the result will be in scalar. That is the scalar which has only magnitude. So now we can see it, the definition of solenoidal vector. That is, after finding divergence of your vector, if the result is which is equal to 0, then it is solenoidal. So the vector point function which has not only magnitude, it has direction also. So if divergence f which is equal to 0, then it is solenoidal. So the definition of curl of your vector, that is, it is continuous and differentiable. The dot product, which is dominated in a solenoidal, whereas in a curl, we can see it, the cross product will be dominating. The between, here we can see what I am circling, the cross product will be dominating. So which is denoted by grade cross f. This f is nothing but our vector point function. Divergence, instead of cross, dot will play a role. So these are the divergence, vector point function, scalar point function, and curl. All these questions are playing the role in our question bank short answers. So the next one is, if that particular, what is a given vector f, which is equal to, we are finding curl f, that result, if it is 0 vector, then it is called irrotational. Very easy way to remember, curl f which is equal to 0 vector, then it is irrotational. Divergent f which is equal to 0, then it is solenoidal. We can see now f vector, that is a irrotational. Then one more function is there. There exists one function, that is pi, which is defined in terms of variables x, y, z. Then what is the connectivity of this f and pi? The connectivity is f is nothing but f equal to grade pi. This pi is called scalar potential of f. So the next one we can say it, show that there is a grade f of r which is equal to f dash of r by r into r vector. This we have to prove it, and the r vector which is written xi plus yj plus zk. So the solution we can say it here, the r vector it is there, xi plus yj plus zk, and write r equal to mod r. We can see here the modulus of r vector. It's nothing but r equal to square root of I x square, for j purpose the component y square, for k z square. Squaring on both sides we are doing, we obtain, this is the result. So the next one, we are going to do differentiating with respect to x, y, z partially. So when we are doing partially with respect to x, this left side is r square is there, that is 2r. Again r we will be doing the differentiation. It's nothing but dou r by dou x, which is equal to, here x square is there, that is 2x. Similarly we have to do partially differentiation with respect to y. When we are doing, we are obtaining the result that is dou r by dou x, which is equal to x by r. Now, dou r by dou y. For that, here is the variable is there, y square, that is y by r. Here, dou r by dou z, which is nothing but z by r. So now, gradient of f of r we are finding. The gradient, this is the formula for the gradient, and this f of r just we have written as it is. Next step, this f of r in the respective places we have taken, that is here, here and here. The three places, the respective, that is with respect to x we are going to do y, z partially. So when we are doing partially, first the function is f of r, that is f which is defined in terms of r. That's what here, the f of r, that is f which is defined in terms of r. Initially, first we have to do f differentiation, that is f dash. F dash of what is defined. Then what is defined, once again we have to do it, that is r. That r is dou r by dou x. That is already in advance we have done it, that is x by r. The same treatment we have to do with respect to y. So plus j f of r. So f dash of r, again r when we're doing, then y by r. Similarly here also k f dash of r into z by r. Here throughout we are noticing that f dash of r which is common. So we have taken divided by r. So the balance is x into I. Here the balance is y into I. Here z into k. This is nothing but r vector. So f dash of r by r, this complete part is r vector. So now we can see it. Find the directional derivative of f equal to xy plus yz plus zx in the direction of vector here, which is given I plus 2j plus 2k at the point 1, 2, 0. Directional derivative we have to find, for which this is the vector function which is given. First, that vector function we will find normal vector, that is a gradient f we have to find. So we are finding gradient f, just f we have taken in the respective places. Then we obtained this one. Now we need in this function what is our dou f by dou x, that is y plus z. Dou f by dou y, it's nothing but x plus z. Dou f by dou z is x plus y. So after finding grade f, we are moving to our question is directional derivative we wanted. The directional derivative for which we need unit normal vector. Which direction that is given in this, the direction of the mutually perpendicular vectors along with it is given I plus 2j plus 2k, for which we need unit normal vector. For that, the given one divided by its modulus. So the modulus is nothing but square root of I before the coefficient, which is 1 square, 2 square, again 2 square. We obtained the result. The down one is square root of 9, which is nothing but 3, which is written 1 by 3. The numerator as it is written, that is I plus 2j plus 2k. The directional derivative of f, this is the formula E dot grade f. So E what is the unit normal vector here up to here which is written. This is already we found grade F in the before slide. So both we have to do the dot product. So the dot product only I dot I exists, J dot J exists, here we can see it, and K dot K exists. So the multiplication, the dot product which is done here at the point 1, 2, 0. That is, wherever x in the above result 1 we will substitute, y is replaced by 2, z is replaced by 0. Finally, we will obtain, this is the result 10 by 3. So very, very important steps for the solution. This is the final solution. To reach very important steps only we discussed it. So the next problem is in the question bank. Find a unit normal vector to the given surface. So this is the surface which is given at the particular point 2, minus 2, 3. So f of x, y, z, which is equal to x square y plus 2xz minus 4. Grade of f, gradient. So this is the formula. Now from this, the connectivity of this, dou f by dou x, we found it's nothing but 2xy plus 2zi plus j as it is. This dou f by dou y, here we are searching where is the y variable. Here is there. That is why partial the differentiation is 1 into x square. The similar manner we have to do it. Dou f by dou z, we obtained 2xk. So at the point 2, minus 2, 3. So x is replaced by 2, y is replaced by minus 2, z is replaced by 3. So after substituting the particular places, this is the value we obtained. But the question is unit normal vector. So for that, the unit normal vector, the normal vector, we found a gradient of this particular function, which is divided by modulus of that particular grade f. So what we obtained, we have written in the numerator, divided by the 2 which is written as it is, square root of I, here minus 1 the whole square, 1, 2 square 4, 2 square 4. So with 2 getting cancelled, this is the result. Finally, we obtained unit normal vector for this function. So the next one is the problem, evaluate the angle between the normals. The surface which is given xy equal to z square. At the points, the first point is 4, 1, 2. The second point is 3, 3, minus 3. The 2 points are given for this particular surface. We have to find angle between them. So now first gradient of f. This particular the surface regarding what is the function which is given, we are taking as f. So this xy minus z square equal to 0, we can write it, for which dou f by dou x. So here x is 1 into y. Dou f by dou y, here y is 1 into x, dou f by dou z minus z square is 2z. So we did now in the respective places, we will substitute. So when we are substituting, we obtained a yi plus xj minus 2zk. So at the particular point 4, 1, 2, x is replaced by 4, and y is 1, z is 2. Here we will replace it. What we are replacing after substituting these coordinate values, that is x, y, z, we obtained I plus 4j minus 4k. That we are naming as n1 vector. Now one more point which is given 3, 3, minus 3. So the same function x, y, x is 3, y is 3, z is minus 3. We will substitute it there and we obtained 3i plus 3j plus 6k. This we will name it as n2. So the next one is theta. This is the equation angle between the normals. This is the formula for which n1 vector into n2 vector divided by modulus of n1 into modulus of n2. So the n1 we substituted n2 and we have to do the dot product. The dot product we know it only I dot I, j dot j and k dot k exist. Here this is a modulus of n1, that is square root of 1 plus 4 square 16 minus 4, that is plus 16. Here 9 plus 9 plus 36. So if you evaluate, calculate, then that is the final result for the problem. Now we can see it, the one more the question, that is if f equal to, which is given x plus 3y of I plus y minus 2z of j plus x plus p z k, they are telling the given function which satisfy the condition of solenoidal, then find out the value of this p. So just in general, we are recollecting the formula. F is nothing but F1i plus F2j plus F3k. The divergence F, because solenoidal, divergence F, the result should be equal to 0. So that formula we recollected, that is dou F1 by dou x plus dou F2 by dou y plus dou F3 by dou z. So the particular places, the partial differentiations values we are substituting, we obtain 2 plus p, but the given function is solenoidal. That is the reason the solenoidal, the divergence F result 2 plus p, which is equated to 0 since the given function is solenoid. So p equal to minus 2 is the result we obtained. The next question in our question bank, find constants a, b, c if the vector, we can see it here f, this is the function I. For I, the mutual perpendicular vector 2x plus 3y plus az. For the j purpose, bx plus 2y plus 3z. For k, 2x plus cy plus 3z. They give here which is irrotational. So the given function our f which satisfies irrotational, that means curl f which is equal to 0. Again curl cross product will dominate. So we will find first curl f. So the curl f, the determinant we have to find I, j, k, they are placed it. Dou by dou x, dou by dou y, and dou by dou z. This is the condition for the particular problem condition, that is 2x plus 3y plus az. This is the given problem that is related to our j mutually perpendicular vector bx plus 2y plus 3z, and the final one is 2x plus cy plus 3z. So we will do now the determinant, we will find it. So for the determinant for this I purpose, we will do the particular row and column to be deleted. This cross multiplications, we have to do it. So dou by dou y, here y related mm, y three terms. Where is the variable y we are searching? Only in the middle one it is there. So y, the differentiation is 1 into c, we obtained it as c. And this one, that is here the minus sign which is dominating here, that is the determinant, while the formulation of it, the rule is the cross minus of this. So this minus is placed here, and dou by dou z, here z is 1 into 3 to be written, this is 3. And the similar way we have to do it here, j which is there, that is the sign minor, that is the position of minus here which is written, and this particular row and column to be deleted. The remaining one we have to do the partial differentiation. For that, here we are searching what is the x variable here which is placed. The x, the differentiation is 1 into 2. And this we are doing the differentiation with respect to z. Here the z differentiation is 1 into a. This is the formulation of determinant sign. The similar treatment we have to give it for k also. We obtained k of b minus 3. So the given problem, the condition which is given, which is given vector a point function which is irrotational, that is it satisfies the condition of irrotational, that is curl f which is equal to 0. So according to that, we equated which is equal to 0, from which here c minus 3, we obtained the result equating 0, c equal to 3. The next one, minus of 2 minus a, from which we obtained a equal to 2. Finally, we obtained, here we can obtain b equal to 3 and a also 2. So now, so far we discussed curl and divergence, regarding divergence solenoidal and regarding curl irrotational. Now we will move to compute the line integral. That is here the line integral one functions y squared dx minus x squared dy round the triangle. To form the triangle, the vertices are given in the coordinates x, y, that is in the xy plane. So satisfying this, first we are going to plot these vertices. The first one, it's a two-dimensional. So origin we have taken and we named it as O, and this is x-axis and y-axis. Minus 1, 0 is there in our equation. So we can see it minus 1, 0, which is plotted in the x negative direction. The next one is 1, 0 that we plotted in the positive direction, B. Then the final is 0, 1. So all the 3 points we plotted in the our xy plane. And now we are joining. We got a triangle, that is ABC as a triangle which is formed. Now we have to find the line integral, that is our, suppose a particle which starts from A. From A to B it moves, from B to C it moves, from C to A it moves. It is a closed curve, that is starting and terminating points coincide. Now we have to find along AB what is the line integral, along BC what is the line integral, and what about CA. Before that, we need BC, this line integral we want it. Here the B, the coordinate is 1, 0, whereas C, the coordinate is C, 1. Thus, passing the equation of the line is which is required. To find the equation, we know the formula, that is So we can see it here also, the equation that is passing through 2 points we studied in lower classes, the analytical geometry. Y minus y1, which is equal to y2 minus y1 divided by x2 minus x1 of x minus x1. This formula we will substitute assuming x1 y1, x2 y2. Then we will be getting this equation of line. Similar treatment we will give it to CA also. We will obtain y minus x, which is equal to 1. So now we can see it, the completed the figure. Here A, B we want it. The particle starts from A, which moves to B. So in the direction of the X direction, it moves. So when it moves to the X direction, X varies from where to where. At a distance of X direction, the particle is moving. That is from -1 to 1, it is moving. So we are going to find the integral over -1 to 1, that is the limit range. What about y? So the y which is equal to 0, then dy which is equal to 0. So we have written x varies from -1 to 1. So we are finding the integral along AB. This is already given in our equation. There is line integral formula is f dot dr, which is already given in our equation. Just we are reproducing here. So now this, if you are taking this, we have to substitute in the particular places. Dy, this is cancelled, y also 0. So completely in this direction calculating the value is 0. Now from our particle, from B it moves to C. So when it moves to C, we can say it here. So this is the figure. From B to C we are moving. So along BC, this is our equation. So one direction we are making, from which we extracted what is y. So y equal to 1 minus x. Dy, it's nothing but minus dx. So now this we have to evaluate. X varies from, we can see it, 1 to 0. So along BC, this is given in our equation, our vector function, 1 to 0. This, what is the value y place? We are substituting 1 minus x. And dy place here, that we substituted here. We have to do the integration to obtain the result of BC. Similar way, now we will move to CA. To find CA, the equation y minus x equal to 1, from which we obtained what is y. We are doing the differentiation on both sides. Our x varies from here 0 to -1. That's what which is written. We will substitute in our function what is y place and dy place. We obtained, this is the integration, 0 to -1 and completely with respect to x integrating, and we have to substitute our lower limit is 0 and upper limit -1. So along AB, we obtained that we have seen 0. BC, this line, important step, we discussed it, how to evaluate. And CA also important, that the step regarding. This is the formula of line integral. This is the function which is given in our equation. We need AB, BC, CA. AB, we have seen the result is 0. So the next BC, if you integrate that integral, -2 by 3, the final one CA is 0. So the result we obtained -2 by 3. So important, the 60% important the steps to how we have to do this problem, the conditions we discussed it. So already the initial stage itself I told this complete step by step the problem solution, which is available in another topic of different video lecture. So now this problem evaluate the line integral. Here the integral over c x square plus xy of dx plus x square plus y square dy, where here we can see the bounded conditions x the coordinate plus or minus 1, for y plus or minus 1 is there. Formula of the line integral is integral over c. This symbol which represents it's a closed curve, that is starting and terminating the points coincide f dot dr. So AB, BC, CD and DA, f dot dr. So we can x which is equal to the points plus or minus 1, y is plus or minus 1, which is given. It's a two dimension, so x and y we have according to the bounded region condition we are plotting the points. So we plotted over the 4 points and joining the points we go to a square, because in the equation itself which is given there is a bounded square region. Now x that is minus 1 to 1, it moves the particle. When it moves from here to here, from A to B, if it moves, then what about y? We can see it y is minus 1. When it moves in the y direction, that is y varies from minus 1 to 1, what about x? And what I am circling, that is x, that's what which is written here, x equal to 1. Now from C, our particle which moves to D, that is in x direction. So we can see it 1 to minus 1, it moves. What about y? Y is nothing but we can see it y equal to 1. Next, from D we are moving to A. That is we are in y direction we are moving. So when we are moving to y direction, we can see it 1 to minus 1. What about x? X is nothing but minus 1. We can see it, x is minus 1. So looking at the bounded region condition, what which is given in our question, we have drawn the diagram. So we can see the direction also, it moves in anti-clockwise direction. So where it starts, just it is a forward and it moves and coming to the starting point. This is very important point. It is a closed curve. So the next one, this is actually the diagram what we have discussed. It's a grouped one which is kept. Now along the AB we are moving in x direction. So x varies from minus 1 to 1. That is the integral over minus 1 to 1. What about y? Y is minus 1. So dy, the differentiation of constant, which is equal to 0. So this is the function which is given in our question. That is along AB, our line integral, we are going to find f dot dr. So we are going to find AB, BC, CA and DA, 4 lines integrals we are going to find. If we add, that is our integral over C. So this is in this what is given in our function. We are substituting wherever y minus 1 and dy is 0. So dy is 0, this is completely vanished. Y place we substituted minus 1. We obtained this and we did the integration. X square, the integration x cubed by 3. X integration is x squared by 2. And the limits we substituted minus 1 to 1. So after substituting upper limit minus lower limit, we obtained the result 2 by 3. So Along AB, this is the result, we obtained it. So similar way, we have to do BC and CD and DA. The four we have to do it. Along AB, that we have seen now practically, 2 by 3 we obtained. When we are doing BC, the result 8 by 3, and CD we are obtaining minus 2 by 3, DA minus 8 by 3. The final result of this problem is 0. So first AB, that is we explained in the complete the way how to obtain similar manner to be this BC and CD and DA to be obtained. So the next problem of our question bank. So this is our question bank problem regarding surface integral. The previous slide what we discussed is line integral. So f dot n ds, where our f is zi plus xj minus 3y squared zk. Our surface, that is x squared plus y squared, which is equal to 16, included in the first octant between z equal to 0 and z equal to 5. We can see our surface S, which is a curved surface, because here the circle equation which is given, that is x squared plus y squared equal to a square. Then the complete the figure, the closed one ABCEA. We are assuming the circle equation as a function of pi. This is our f which is given. This we have taken as pi. Z dimension which is given from 0 to 5 units. So we are drawing, it's a 3-dimension. We can see it. Z is there, X is there, and mutually perpendicular also. I, J, K, 3 are there. So the directions we are mentioning X, Y, Z, and the middle one is O, origin. So we are drawing actually the figure. So we can see the curved cylinder. From this, it's not a 3-dimensional completely, we are not going to calculate. Our question is only surface integral. So the surface integral, that already from 0, that is this unit which is given from 0 to 5. What about here this y direction? The y direction, this we know it as 0, 0, 0, that is the origin. If you substitute x plus 0, y we will be getting 4, plus or minus 4, but ours is first octant, so positive we have taken. This z equal to 5, which is given in our question. So when we are this place, our z is 0, the surface, the third dimension. Practically also in the figure we can see it, the geometrical figure which is drawn here. This is the surface. If this is the z-act, the third dimension, which is not appearing here. So z equal to 0. So we can normal vector, the gradient of pi we are finding. Our pi is x square plus y square, which is equal to 16. Now gradient pi, that is dou pi by dou x plus dou pi by dou y plus dou pi by dou z. So this x square, it's nothing but 2xi. This differentiation is 2y. So we have written here. We need a normal vector we found, that is gradient pi we found. To convert that normal vector into unit normal vector, that is the formula. This divided by its modulus. So 2 of xi plus yj divided by 2 of square root of, here this is x square plus y square. The 2 getting cancelled, xi plus yj divided by square root of x square plus y square. So here we are substituting the value of, here we can see it, the 2 we have taken, x and y. So from which we can y value we know 8 to 4. We can see the diagram also. So we can see here, which is given here z equal to 0 to 5. So we obtained the result xi plus yj divided by substituting 4 plus 4. So from here y equal to 4 we are getting, and the x also we are getting. So square root of 16, which is nothing but 4, we obtained it. So this is the figure, the grouped figure, we kept it. Now yz is our, here we can see it, yz. R is the rectangle, that is this OBCD, that only we are going to do the calculating part. So F dot N ds, so F dot N, the ds it's nothing but y and z should be there. N dot I, yes, z should be there. So N dot I, the F which is given, that is the given question. F dot N first we are finding. F which is written, the dot product is as it is, and N is the unit normal vector. Just now what we obtained. This both we have to do the dot product. That is only I dot I and J dot J exist. The K here, there is no K term, so it is vanished. So after doing the dot product, we obtained 1 by 4 of xz plus xy. Now n dot I we are finding, because to substitute in the formula, these are the terms are required. So we obtained x by 4. Next, the x square plus y square, which is equal to 16 in the xy plane. If x equal to 0, y equal to 4, we are in the first octant. So this is the formula for the surface integral. Already we found f dot n and dy by dz, it is our plane is yz plane. This is also in advance we found. Everything what all we found in the particular places we substituted. Here we are finding x is common and this getting cancelled. 4 cancelled. We obtained, that is z from 0 to 5, y from 0 to 4. This is from the equation x place we have substituted 0, we obtained y equal to 4. dz by dy, the dimension we have taken from the figure, which is very clearly it is mentioned that it is yz plane, and evaluating, this is the integral, double integral to evaluate the surface, that is surface integral doing, we will obtain the required solution for this problem. So what are the important steps? Everything to obtain the result we discussed in this problem. So the next problem, f which is given, that is 2xz I minus xj plus y square k, evaluate, which is a volume integral, where V is the region bounded by the surfaces x equal to 0 and x equal to 2, and y equal to 0 and y equal to 6, whereas z, which is given in a curve, z equal to x squared, z equal to 4. So we can see it's a 3-dimension. So looking at the question itself, I, J, K and X, Y, Z, the 3 are playing the role. So we are plotting the points which is given in our question, A, B and C. So we plotted 2, 0, 0, here 0, 2, 0. The final one is 0, 0, 2. and we joined the plotted points, we got a triangle. So what is our volume we have to find? So we should not forget we are evaluating volume integral. That is complete the three-dimensional put together the region, the bounded region of volume integral we have to find. We can see the vertical lines. This is the volume we are going to find. So this is our given function, the volume integral, that is a triple integral volume. This is the function which is given in our equation. dv, three dimension, dx, dy, dz. We can see I. The better the equation itself we have seen it, z related to that, the curve which is given, that we are putting better inside to make our integration very comfortable. So here related to I, we have taken out the 2xz is playing the role, and minus j, here related to j, we have kept it, here related to k, and dz, dy, dz, dx. First, we will be focusing on interior one. With that result, next we will move to the middle integration with respect to y. The final one we will be doing with respect to x. This is the step to be followed here also, here also. After doing the integrations, that is in inner, middle and outermost, we will obtain this particular problem required solution. So the next problem we can discuss of our question bank, that is f equal to xzi minus y square j plus yzk. That is evaluating f dot m ds, where we can see it. S is the surface of the cube bounded by x equal to 0 to a, y equal to 0 to a, and z equal to 0 to a. It's a cube, so it has 6 faces. All the faces are equal. So the face, the name put together, P, Q, A, S, C, or B, O. If we join the cube, we will be getting. For that cube, we have to find the volume. Here, evaluate the surface integral which is given. We can see it, the surface we will find out. The complete the three dimension if we take, it comes under volume, because in this particular question which is asked to calculate surface, because according to Gauss divergence theorem, surface integral, that is f dot and ds, which is equal to triple, that is volume integral divergence of that particular function. As the question which is asked is surface, we are going to find the surface area of 6 faces. So we can see it, we have drawn our cube. This is our f, that is a function. This is the bounded conditions. According to that, this geometrical figure of cube which is drawn. Now the 6 faces, step by step, we have to do surface area. So we are taking here the first face, we have taken PQAS. We can see it, which is in a different color shading is there, the lines. Phase 1. This line first, what I am underlining, shading, which is parallel to which coordinate system? That is our Z. That's what here dz which is written. Now this vertical line parallel to which one? Y, dy. So ds equal to dy dz. So from origin to it moves to x direction at the point A, and the figure of this surface is PQAS. We can notice it here. So from the origin to x directions, it is moving at a point A. This region we are naming as R1. So why it, we can see it 0 to A, it moves. Z also 0 to A. This is the dimensions to calculate this y z plane we are evaluating the surface area. So if it is, this is in the direction of z, this is in the y. So the third one, that is, which is perpendicular to this surface, is our x direction. That related to that, the mutually perpendicular vector from that direction, that unit normal vector is I, which is drawn from out, that is I we are taking. So first, to substitute in our surface integral formula, that is integral over s f dot n ds. F dot n initially in advance we are finding, that is 4xz, x equal to a. So in this place where x that we are substituting, so ours is dy dz plane, z equals 0 to a, y equal to 0 to a. Anything we can take it. If inner one also, if you are taking y, nothing wrong in it. So we are evaluating the integral, we will obtain one result. That is the result of this R1 region. The similar way we have to find other 5 phases we have to calculate. This now we calculated it. PQAS. This the next phase, that is, this is the region of R2. If you are noticing these two figures, here PQAS is just opposite to this. The dimensions, that is the surface area, that is the YZ, dy dz, there is no change at all, but the change will be coming just opposite direction. Here n equal to I we have taken, here n equal to minus I, and x is playing the role of 0. That we will be substituting in the particular places. How we have done it, this phase, similar way it should be done for this R2 region. The next region we have taken RBQP. This we are finding this line which is parallel to x, and this is parallel to y. That means we are finding dx dy. This is xy plane. Then if it is, this is x and this line which is parallel to y, then the next side, the unit normal vector is k. This the fourth region, this opposite to this, here our unit normal vector is minus k. The fifth phase we have taken RPSC. We are noticing this is parallel to our z and this is parallel to our x. So dx dz. Here ours is, we can see it j, and here which is minus j. So the unit normal vector opposite, the negative signs will be playing the role. All the 6 phases we have to do the evaluation. So this particular problem, it is already in the YouTube, the video which is released under surface integral. So thus evaluating, this is the result. The second one 0 we obtained, third one a power 4 by 2, the fourth one is 0, fifth one is minus a power 4, the last one is 0, we obtained 3a power 4 by 2. As this question which is asked to find only surface integral, we found that one. That only important steps we discussed, as it is question bank discussion. Next, the same problem, suppose in case if it is asked to find, verify Gauss divergence theorem, we will find divergence of a volume integral. We have to get compulsory the result 3a power 4 by 2 if we are getting Gauss divergence theorem which is verified for this particular problem. So next we will very important integral theorems which are playing in our vector calculus, that is Green's theorem. So this is the function which is given in x and y direction, and two curves which are given, that is the parabolas which are given. This is the line integral which is equal to double integral. That is the transformation between line and double integral is our Green's theorem. This is the bounded region of that. We will draw the geometrical figure so we can see it. That is looking at the question, the bounded conditions, it is xy plane, x-axis and y-axis. This is the origin, that is O 0, 0. We can see now this parabola which cuts at x-axis, that is x equal to, we can see here, this we can write y square equal to x if you square on both sides. So y equal to root x, this is the parabola, and this is y equal to x square. Now this is the point, it starts from 0, 0, 0. We need this, both the parabolas intersecting this point. Using these two curves, we can find the point is a of 1, 1. Now the Green's theorem to be, we have to solve using that. So this is the Green's theorem formula. This is the function which is given, the vector point function in a x and y direction. M dx, we are comparing with our Green's theorem formula, that is m dx plus n dy, that is the format. So this is nothing but m and this is nothing but our n. So dou m by dou y we are doing partially, that is here we can see it minus 16y. Here we are noticing here dou n by dou x, that is here x, the differentiation is 1 into minus 6 pi. So here that the particular places, this dou n by dou x, dou m by dou y, what is obtained result we substituted, and we have to do the integration. This is using Green's theorem we are evaluating. So the next problem using Stokes' theorem. So we have to read the question very carefully using Stokes' theorem. That is only one side. Verify if it is there, both left and right, both the sides we have to evaluating. We have to make the result equal. It's only using, that is the line integral, the function which is given, and the vertices which are given. So we can notice it, the origin, 3 vertices, 0, 0, 0, 2, 0, 0, 2, 2, 0. So Stokes' theorem formula, that is line integral which is equal to surface integral of, that is curl f dot n ds. So we can see it here. So looking at that, yeah, it's a beautiful doubt actually. It should ring in our mind that here x, y, z, x, y, z, this is a x, y, z, the format which is given, the coordinates, but here the diagram we are drawing only 2 dimension. The reason is, if you are noticing in the coordinates, all the third dimension which is equal to 0, that is the main reason we neglected the third one. Now x and y, we plotted 2, 0 and 2, 2. So we are joining, we got a triangle. This 2, 2 which is obtained from here. So if we, this is nothing but y equal to x, because you can see it, x and y both are same. You can write x equal to y. So we can, the direction also which is given, that is if the particle which starts from the origin O, it moves to A, from A to B and B to O. So now our integral is, we are going to evaluate this one. So we integral over the double integral, that is y from, here we can see it, y from 0, which touches that equation, y equal to x. And what about x? We can see it here, x equal to 0 to 2. So from this question, that is the interior one, we kept it for the curves. That is a y x equal to y. There is a straight line. Outer one, we kept it for the real numbers. Evaluating this is the integral, we will obtain to the result. So now we will come to a conclusion of this vector differential calculus. First, vector and scalar point. The vector, it has magnitude and direction. Scalar, it has only magnitude. First, what is a gradient? The gradient, it's nothing but the symbol, and this is a mathematical symbol for a gradient. I dou by dou x plus j dou by dou y plus k dou by dou z, and which is connected to our particular function, then that is a normal vector. To find the unit normal vector, it's whatever it is that, suppose f is a vector function, gradient f divided by modulus of that particular gradient f, it's nothing but unit normal vector. The unit normal vector dot product of the vector function, which gives a directional derivative. Divergence, we found it is related to scalar point. Curl, which is related to our cross product, which is playing the role. If the curl f which is equal to 0, then it is irrotational, and div f which is equal to 0, then it is solenoidal. Everything related to such questions which are dominating in our question bank, which is discussed. Then we moved to line, surface and volume integral. The line integral, that is integral over Cf dot dr, surface integral, which is to calculate the area of the surface, double integral, which is used in 2 dimensions. For the volume integral, to evaluate the volume, the triple integral, which is used. Integral theorems, we discussed mostly Green's theorem and Stokes theorem. The surface integral itself, the Gauss divergence theorem also, which is playing the role. So completely regarding vector differential calculus, what are the important, the question bank questions, the steps, we discussed it. But once again, I want to say that if complete the solutions already, which is available in the YouTube channel, the videos already released. If complete solutions is required, we can watch over there. Thank you very much to you all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.